Write ionic equations for the reactions between the following: the amphoteric metal chromium and potassium hydroxide solution. So these are our two reactants. We have chromium reacting with a hydroxide solution. Because potassium here is going to be a spectate ion, we cancel it out. And it's going to be in solution, which means there's going to be water present. So this is our ionic equation. It's going to form a chromate ion, as you can see here, and also our hydrogen gas. Now, when you're going about balancing it, first you would look at how many hydrogens you have. You have 4 hydrogens here and 2 hydrogens here, which gives us 6 hydrogens. But we only have 3 hydrogens on this side, so you would put a 2 in front of the water and then a 2 in front of the OH ion. Now you would have 6 hydrogens on this side. For the time being, our hydrogens are balanced. Now let's look at it again. We have 2 O's and 2 O's. Now let's just balance our oxygens. To balance our oxygens, you would just put a 2 in front of our chromate ion. So you would get 2 oxygens, 2 times 4 is 8, and we have 2, which is 2, and we have 2 oxygens here, that gives us 4. So our oxygens aren't balanced yet, but we'll be working towards it. Now we have 1 chromate ion here, which means 2 chromiums, but we only have 1 chromium here, which means we have to double our chromium. So you put a 2 in front of the chromium. Now what you do is we look at it again and we see that our hydrogens or our oxygens are not balanced yet. So to balance our oxygens, we just need more oxygens on this side. So to gain our oxygens, we can add 6 here. But what we'll be doing is we'll be working with our water. So if we put a 6 in front of our H2O, now our oxygens are balanced. But this unsettles our hydrogen balance. So to balance our hydrogens, we just work with the hydrogen gas here. So that way it's safer. So we have how many hydrogens on this side? We have 2 plus the 12 from here, which gives us 14. To balance our hydrogen, you just simply put a 3 in front of the H2. So that gives us 6 hydrogens over here, and we have 8 hydrogens over here. So that gives us a total of 14 hydrogens on this side. So that is how you would balance a chemical equation. Now part B, it says the amphoteric metal zinc and the solution of sodium hydroxide. Now sodium hydroxide is a base. So we have zinc reacting with the OH ions from the sodium hydroxide, because the sodium is a spectate ion. It gets cancelled out. And there's going to be water present because it's in solution, giving us our zincate ion, which is 2-, and our hydrogen gas. Again, when you're balancing this, let's just look at what we have to balance. We have to balance our hydrogens and our oxygens. So in order to do that, you just simply put your 2 hydroxides and 2 water. So that'll balance our hydrogens and our oxygens. And we're not going to do anything with our zincs because they're already balanced for us. That's how you would go about balancing these 2 equations. And you can see how you cancelled out your spectator ions. That way it's easier. Moving to question 21, it says, compare the products formed in the reaction of aluminium with hydrochloric acid and with a sodium hydroxide solution. So you'd have to compare. Sometimes you may do this in a table, but also you can write it as a paragraph. Aluminium chloride is formed when aluminium reacts with hydrochloric acid. So aluminium chloride is formed when it reacts with hydrochloric acid. And AlCl3 is aluminium chloride. So this is an ionic salt because this is a metal and this is a non-metal, with aluminium acting as a trivalent cation because it has a trivalent. In other words, 3 valencies. Sodium aluminium hydroxide forms when aluminium reacts with sodium hydroxide. Now, sodium aluminium hydroxide is also formed when this compound reacts with the sodium hydroxide. So we have sodium aluminium hydroxide. This is how you would go about writing it. We have our aluminate ion joining with a sodium ion, and that's how it's produced. It is a complex salt where aluminium forms as the anion. So this part is the anion with 4 hydroxy groups. So this is a 4 hydroxy groups. As you can see here, 4. That's why it's called a 4-hydroxy group. When it reacts with the aluminium, it makes the aluminate ion. Now the aluminate ion reacts with the sodium. Remember that the aluminate ion has a valency of -1 and sodium has a valency of +1. So it gives us Na, big brackets open, Al, the little brackets giving out OHs, 4 of them, and you would close your big bracket. This then acts like a polyatomic or a complex ion. In other words, this is a very complex ion and it has different, in other words, polyatoms. It's made out of different atoms. In both reactions, hydrogen gas is produced. Now you can see how they have compared the two. And they also given us what's similar about them and what's different. And that's very important with the word compare, because this is a key word there. When it says to compare, you do have to name the similarities as well as the differences. So you may do it in a table, but if you have more information like here, it's easier to do in paragraph form. Now let's just wrap up what we have learned. We learned about metals that react with both acids and alkalis, and they're called amphoteric acids or amphoteric substances.